For our very last order of business today, we want to quickly show you how you can represent parts per billion as a concentration unit definition as micrograms of solute per liter of solution rather than ppb. These are both very common ways of expressing the concentration unit parts per billion, and you need to be fluent in both of them. This dimensional analysis logic also works for showing how parts per million can be expressed as milligrams of solute per liter of solution. This doesn't correspond to a worked example problem in Harris. Instead, this is some key use of dimensional analysis that Harris kind of glosses over in the text, but it's important. I want you to see how you can use these types of dimensional analysis pathways to come up with alternative expressions for different concentration units, because it's this type of logic which we'll be using routinely when we talk about converting concentration units from one unit to another, which will be our main focus on Monday. So all I want to show you here, this is essentially a concentration proof. I want to show you that 5 parts per billion calcium 2+, or 5 grams of calcium 2+ per billion grams of solution, converts naturally and in a relatively straightforward manner to 5 micrograms of calcium per liter of solution. There's only 2 keys to this thought process: basic dimensional analysis thinking, and the second is to recognize that because a parts per billion solution is a trace or ultratrace solution of the analyte, the density of the solution should essentially be the same as the density of the solvent. So if we have a very dilute aqueous solution, much lower than 0.1 molar, so like obviously parts per billion or parts per million qualify as lower than 0.1 molar concentration, something that we'll see in more detail on Monday. As long as your aqueous solution is very dilute, you can assume that the solvent's density is the same as the density of the solution. This is not a blanket assumption we can make. We're only making it because we know that a part per billion or a part per million solution must be very dilute. So knowing this, for our dilute aqueous solution that the density is equal to 1 gram of solution per milliliter of solution, we can use the following thought process to get to our alternative statement of micrograms per liter as an alternative way of expressing parts per billion. So we start with the definition. 5 grams of calcium 2+ per billion grams of solution, just like we have it up here, is the definition of a 5 part per billion calcium solution. Knowing where I want to get to, which is micrograms of solvent per liter of solution, I'm going to use dimensional analysis and conversion factors to convert the mass of solution in the denominator to a volume of solution in the denominator. To do that, I use the density of the solution, which we're assuming, with good reason in this case, that the density of the solution is the same as water. Say I'm going to multiply by 1 gram of solution for every milliliter of solution. As with any conversion factor, I'm putting the unit I want to cancel opposite where it is in the original measurement. So here the gram of solution goes on top. Cancel, cancel. Notice that I used solution. I'm writing everything as explicitly as I can so I don't lose track of what I'm measuring. Here's grams of solution in the denominator. Here's grams of solute in the numerator, and I'm only working on the grams of solution. So grams of solution cancels with grams of solution. I have 1 milliliter in the denominator of my conversion factor. So now I would have 5 grams of calcium per every billion milliliters of solution. To get to my final concentration statement of micrograms per liter, now I'd like to continue just working on the denominator and convert this from milliliters of solution in the denominator to liters of solution in the denominator. And this I can just do with the definition of milliliters. Because a milliliter is a thousandth of a liter, there are 1,000 milliliters of solution in a liter of solution. Again, milliliters and milliliters are going to be on opposite sides, so they cancel. And now we see that there should be 5 times 1,000 divided by a billion grams of calcium for every liter of solution. And if you do the math, 5 times 1,000 divided by a billion, this simplifies to, as a number, 5 times 10 to the negative 6th grams of calcium per liter of solution if we express it in scientific notation. If you prefer standard notation, that would be the same as 0.000005, or 5 zeros before the 5, grams of calcium per liter of solution. From here, this looks really similar to an alternative statement of parts per billion. We just need to remember that by definition, the SI unit prefix micro means times 10 to the negative sixth. So if we have 5 times 10 to the negative sixth grams of calcium per liter of solution, that's the same as saying that we have 5 micrograms of calcium per liter of solution, and that's our alternative statement of parts per billion as a concentration unit. As long as you're talking about a solution in water, you can use parts per billion and micrograms per liter interchangeably. Using the same thought process, one of the post-lecture exercises will ask you to prove to yourself that you can also come up with the alternative units for part per million as milligrams of solute per liters of solution using the same logic. So that's it for today. Make sure to check out the post-lecture exercises that each time they're worth points, but not too much, just 2 points for today's post-lecture exercises. And I will see you back in class on Monday.